Well, good morning. I'm the last speaker before lunch. I've been informed that the rest of the afternoon has been canceled, and I'll be talking to you for the next 6 hours on building materials. So I hope you're ready for that. Actually, first I'd like to thank the NIJ and the FBI laboratory for inviting me to speak today. I'd like to start off by a phrase of a famous microscopist who many years ago stated, and I quote, "Good science begins with good microscopy." And I think that's a good place to start today. Although I examine many different types of materials ranging from vomit, cat litter, owl pellets, and all different types of materials, I like to go back to my roots, and that's geology. So I consider myself a forensic geologist. I think amongst the room today, I think just about all of them in the country or North America are here. So building materials, of course, is an area which I really enjoy because a lot of it involves geological materials. Well, my talk today is going to be mainly in two parts. The first part is going to be a general overview of what building materials really are in the context of forensic science. And the second part will be, because there's not enough time to talk about all the individual particles involved in building materials, the second part will be trying to emphasize three very fascinating things: bricks, hardened concrete, and wood plastic composites, to give you a little bit more of an idea on how they're manufactured, how they're made, and what we can do with them. So first of all, pretty simplistic, what is a building material? In this case, any material used for construction purposes. And just about anything that's ever been around has been used as a building material. But for the talk today, I'd like to stress building materials used to create or that are in homes and structures and materials that we're examining at crime scenes many times. Well, building construction types. And I just came up with these. This is not rocket science here, but first one, wood frame construction. At least in the Northwest, in my neighborhood, when I walk around at a new home site, you see the overwhelming amount of wood materials being used, from dimensional lumber, plywoods, a whole array of wood structures. And they range in apartments, manufactured homes, modular homes, residential structures, and motels, hotels, things like that. Steel and glass office towers. And those types of materials you would find, of course, in office towers, shopping malls, industrial complexes. Then concrete, and the CMU means concrete masonry units. Those are the blocks. Of course, there's a lot of overlap amongst all these, but I think of those in industrial complexes, bunkers, missile silos. I include missile silos because I actually had a crime scene in a missile silo one time. And also, amongst all of those types of structures, you have an assortment of other things, some less common and more common than others, including brick, stucco, natural stone, mud, adobe, caves. Tabby construction, I threw that in because in the Southeast, in the colonial times, they would grind up seashells and shells and lime and produce kind of a cement. You can still see that along, I know, the Georgia coast on some of the barrier islands. Igloos, not too common, not going to find much there. Thought I'd throw that in though. Yurts, again, those were usually made out of goat skin, but today they actually make those out of synthetic materials and canvas. You can go on day hikes and cross-country skiing from yurt to yurt. That sounded kind of funny. Teepees, straw, and car tires. They actually make houses out of car tires in my neighborhood. Not really. Building materials, well, I break them down into two major areas: natural materials and unnatural materials. No, man-made materials. First one, rocks. I think there's a pointer here. Rock can be used to make building blocks, essential, like in the pyramids on the Giza Plateau. There's a gentleman standing by one of the large blocks. Now those are unique in a way because they're limestone and they have these large foraminifera. I think they're nummulites, not sure the correct pronunciation there. Clay is another category in which you can produce bricks and adobe structures from clay. Thatch and brush roofing materials are common in Great Britain, I believe, still today. Wood and lumber, dimensional lumber, and asbestos, still found in insulation and fireproofing material. Then all the other ones are man-made materials. They can range from Portland cement, which is used in the production of hardened concrete, engineered wood, in which you can make plywood and wood plastic composites, amongst many other things. Gypsum, that material is used in wallboard, which is one of the more common ingredients or materials you'll find in forensic examinations, particularly on the nose of bullets. Fiberglass, and I should include glass wool, rock wool, mineral wool, slag wool. Those are found in insulation products, amongst other things. These are just some examples. Plastics, siding, pipes, laminates. Coatings, of course, paint. Glass, windows, mirrors, lighting, glass blocks. Metals, structural components, and trim. Well, this isn't a Rick Steves narrative on travel or a travel log, but I thought I'd throw in a few more indigenous types of structures that are seen. Back up a bit. Of course, on the far left, there's your grass thatch roof. And they do use grass in the Northwest. At the end of the harvest season, they have the stubble in which you can grind up and make a plywood type material out of grass. Then, of course, there's a lot of parts of the world in which there are many people that still do live in caves. Okay, and these are yurts actually in Australia. And the adobe brick type construction, which was used by the Anasazi in the desert southwest of the United States. And the upper left-hand corner is my supervisor's home in Spokane. She lives in a castle. And this is my home on the far right because I'm rather goofy and eclectic. Actually not. And these are some just clay brick structures and a grass home being constructed. As you can see, there's some of the more modern types of materials, grass. Okay, here we have a log home. Log homes are very popular in the Northwest. Igloos, no, not too much, especially in Florida. But the bottom one, this is what we usually see at crime scenes, and the material you usually get from building materials come from that type of structure. Rundown shacks, mobile homes, hotels, motels, stuff like that. Large office towers like at Dubai on the left, the Eiffel Tower, and the collapse of the trade centers. And I bring that one in there to remind me of my roots actually when I worked at Macron Environmental Services with Tom Hopen, who's in the audience, and Maureen Botrel. This was one of Maureen Botrel's clients was the Port Authority of New York, and she was responsible for identifying the asbestos-containing materials in the trade towers to figure out what companies made the products by doing constituent analysis. For instance, if it was a ceiling tile which had asbestos, Maureen and I and the people in the group would identify all the parts in the ceiling tile, from the glass wool, could be the starch paste, it could be the paper fibers, the asbestos, and determine what company made that product for litigation purposes, because they'd sue the company who made it. Well, how important is this in casework anyway? Oftentimes in my work, I usually see them on the nose of bullets. They try to determine bullet path. Could it be sheetrock on the nose of a bullet? Could it be glass wool, mineral wool? And transfers during forced entry. The perpetrator might be coming through the roof, cutting a hole into it, and he might get paper fiber insulation in his hair, which could be picked out and compared to the insulation in the attic. Or it could be hit-and-run accident reconstructions. For instance, if a concrete wall falls down on a lady on the bathroom, which occurred in a case actually in Oregon, one of Brad Putnam's cases, you could compare the concrete particles on the front of the car to the concrete at the site where the woman died. Whether debris worked into soil, seeing I do soil examinations, oftentimes in urban settings you find that. You'll find bits and pieces of building materials in the soil. Impression evidence, I've seen that with sheetrock dust, where someone's walking through a building site and they have their shoe prints in sheetrock. Then just quickly, the health hazards of asbestos in particular. I've had cases where a huge piece of transite board is in the laboratory for impression analysis. Has nothing to do with the asbestos in the transite board, which accounts for about 50%. And it was just laying there up against the wall with a sticker on it, not encapsulated in a plastic bag. So just be aware that some of the materials you may see contain asbestos, to make sure they're properly analyzed in a hood. So what's the probative value of all this anyway? Typically it's associative evidence. And of course, the more different types of building materials you have in an item, the more stronger the conclusions can be. That's quite common in anything we do. But I like to emphasize the intelligence or investigative leads that can be found. First of all, with aggregate and concrete. For instance, in the Northwest, a lot of the aggregate comes from the belt supergroup formation. It's rocks from like near Glacier National Park. Well, they get weathered and worn and transported by glaciers and giant floods to the Northwest, and that's mixed in the aggregate. You're probably not going to find that in Florida. As example, also in Florida, as I was traveling down the highway, if you're looking at the asphalt, the roads are kind of a light colored asphalt. That's because of the sand intermixed with the asphalt. In the Northwest, they're kind of a greenish purple due to that aggregate I previously mentioned. And we mentioned earlier product identification, which we did at Macron. Well, here's an example, for instance. In the upper left-hand corner is a nose of a bullet with some white powder material on. And the investigating officer wants to know, did this go through a wall, a ceiling, a floor before it was found? Well, after closer examination using a stereo microscope, and why this light doesn't work too well, okay. You can see the white powder and see some fibrous material intermixed with it. In phase contrast, you see now large clumps of that material, which doesn't offer much of a conclusion. But at higher magnification, using 100x oil immersion, you can start to actually see some of the individual particles of gypsum, which is a major component in sheetrock and wallboard. But there are some trace components too, which can occasionally be found, some other hydration states of gypsum, such as hemihydrate and, I don't have anhydrite in there, and also little pieces of calcium carbonate. And then again, if you want to carry it another level, you could do electron microscopy and look at the structures of the gypsum and elementally analyze it, containing calcium and sulfur, of course. Then that you have all that information and the paper fibers that I forgot to mention, you can then try to figure out where did this come from. Of course, there might be a hole in the wall, which is rather obvious, but if it's not. Just to give you an idea how many different types of materials there are, and this is just a brief example that contain gypsum. Wall boards, old lath and plaster walls contain gypsum, acoustical ceiling tiles or applications, fireproofing, and gypsum sheathing. Another example with bullets that contain wood in the nose. The one on the left is actually hemlock trim molding, while the one on the right is a glue laminated beam. We don't have time really to discuss the analysis of wood. That's a whole specialty, of course, in its own right. But you can identify the species using microscopy, whether it be a hardwood or a softwood, and you can actually identify that using, first of all, if you have a large enough section, you can make a little block and look at the three structures of the wood, the cross-section, the radial and tangential view. If you have more of a fibrous component, you can look at the actual cellular structures and identify what species it is by what are known as vessel elements in the wood. And then again, there's all engineered wood products, such as melamine surfaced materials, and then we have different types of composite wood structures, lap siding. I'm trying to go through these rather quickly because I have a lot of slides and I'll probably run out of time if I don't. And I teach a class occasionally in building materials, and what I like to do is build these little miniature walls, and then this was the old way we used to do it, where we'd position the wall with wet phone books behind it and shoot it with a 9mm Glock hollow point and collect the debris. So we'd shoot through the front surface and collect the bullets, then turn around and shoot through the other side and collect the bullets. Then the students have about 5 or 6 or 7 or 8, 9 walls, and their job is to determine with all the known bullets that I shot through the materials, which wall did it go through and which direction did it go through. And this is just an example showing a wall containing certainteed vinyl siding, firestone sheathing material, strand board, and fiberglass in the center. And the opposite side has a wall board and it's painted on the surface with a specific kind of paint. Well, now how to classify building materials, to teach or to examine these things, to make some method out of this, to the madness. You can think of the raw ingredients and what they look like, and then determine, for instance, in Portland cement clinker, this contains limestone, shale, sand, gypsum, amongst other things. So if you look at those individual components first, then you can look at the end product, Portland cement clinker, and compare the two. Then I like to think of them as friable versus non-friable materials, such as insulation. It's easily transferred from person to person, versus steel, which isn't, unless it's cut and ground and it's in that form. Gypsum wallboard plaster is easily transferred, versus plastics that don't. You run up against a plastic pipe, it's not going to do anything unless it's cut or sawn. Then I like to examine the products themselves, such as whole categories, wood plastic composites such as Trex decking, cement board, examples such as hardy plank, spackling powder, and asbestos containing materials. Now I'd like to talk about 3 specific building materials in a little bit more detail, those being wood plastic composites, hardened concrete, and bricks. Well, what's a wood plastic composite? First of all, that's a little bit of a misnomer when they use wood plastic composite. I think a better term would be cellulose plastic composites because they're not all wood. Well, one person's definition is any composite that contains wood and thermoplastics. What I'm talking about here are those people that are familiar with like Trex lumber used for decking material. It's a more modern type of ingredient that's out on the market now. Well, thermoplastics, usually the ones they're using are polyethylene, polypropylene, polyvinyl acetate. Well, they have a long history, actually. Bakelite was one of the first products, which was phenylformaldehyde and wood flour resin. A little bit of trivia, the first Bakelite compound was used on the gear shift of an old Rolls Royce. If you ever asked in court that, now you know. What do we have here? In 1983, the Lear Corporation started to produce interior auto panels using polypropylene and wood flour. Then the precursor to Trex is a company called AERT. And they produced the polyethylene wood flour making deck boards and landscaping timbers. And the Anderson wood line, too. Well, what are the materials in wood plastic composites? Polyethylene. That can be recycled or virgin polyethylene. Polypropylene, polyvinyl chloride. Then you have your ABS. And now what are the wood types they use? Well, just about anything. Anything cellulosic they're putting into this material. But some companies use different types of materials, which we'll get into in a moment. Down to about the 10 to 80 mesh grain size. Like recycled wood pallets, furniture waste, rice, bamboo, straw, peanut hulls. It's about a 50-50 mix, the ratio between the wood and the cellulosic ingredients. And there are some proprietary ingredients, which I can't tell you about. No, I don't even know what they are. But they are light stabilizers, pigments, fungicides, and foaming agents. Well, it's a good deal because there's so much waste going on with these. And I'll put my pitch in for these water bottles, these disposable water bottles that we buy all the time. I don't like those at all because they're terrible. But they do make recycled products out of them, such as we see here, recycled polyethylene. Well, what are the different things you can make? Well, mainly decking right now. It says 20 manufacturers, is about 33 actually that I found, that make wood plastic composites. But windows, door components, landscape timbers, picnic tables, roof shingles, siding. In the near future, pallets, flower pots, shims, cosmetic pencils, hand tools, hot tub siding, office accessories, microscopes. No, I just threw that in. See if you're awake. What else do we have? You can see. You can read that. I'm not going to read that. This is what they look like if you haven't seen them before. Decking material. I just had a deck built for our house, and I just love the way they produced it. And I got little samples of the decking. Decking, flooring, panels, cladding, molding, trim, lumber, even injection molded parts are made out of this material. Now, I don't profess to, I'll have to admit I got this off of a website. This is not original, as you can see. I don't understand a lot of that. But these are just general pictures of different types of wood plastic composites. Again, this is from the Recycled Plastic Lumber, the Environment and Plastics Industry Council and Corporations Supporting Recycling. And what we have here is a generic schematic of how they do this. They have a container with the plastic material, which of course is in a fluid state, and the wood fiber material, or cellulosic material. Then it's extruded out with an extruder to make the lumber or the product you're interested in. And I'm not really sure what a calibration tank really does, but then they cool the product, then they emboss the product or squish down onto the material like a wood grain design. And then they saw it and stack it and sell it to Americans, like us, because we have a lot of money, I guess. And then what do? Now, because we're international, I thought I'd throw in some companies around the world that make this stuff. Biologic is a Belgian producer. Anybody from Belgium here? Nobody? Okay. Anyway, this is a product called Bioline, composed of wood fibers. And many of these companies actually supply the pellets, and then another company makes the product. And these are the pellets. And if you're interested in their address and telephone number, there they are. Now here's a company from Australia, from Perth, for our Australian people here. Actually, their company that they make the products in China, Jiangsu province. But they use a lot of wood waste, such as you can read there yourselves, hardwood, softwood, plywood, peanut hulls, bamboo, straw, mix it all together, and the different types of plastics. Now here's a local company in America. I thought this one was interesting. They use recycled pine and juniper, invasive shrubs and bark in their product. Now I bring these all up because I think potentially you could differentiate this company's product, say, from a Trex product, at least. If you have enough material, that is. And you don't need much, as we all know. But they're making signs and dimensional lumber, dimensional letters, spindles, tool handles, and other products in the near future. Certainteed, another American product, recycled maple wood flour they use. And I doubt they use only maple wood. Well, here's an analytical scheme using stereomicroscopy. What do you do first? Of course, the stereoscope. Look at the adhering trace, like DNA. No snickering. Okay, that's better. Then you can look at the texture, the color, the volume percent estimates between the cellulose and the plastic material. And many times there's homogeneous plastics versus clumps of plastics in this material. Weathering features on the surface, other fixtures, screws, clamps that could be there. And you can particle pick for PLM analysis, FTIR, and make thin sections if you'd like. And with PLM, you can identify, of course, the wood species, if there's wood in the material, or if it's rice hulls, you can differentiate rice hull from wood, and the pigments. And by SEM, again, pigment ID, the filler components, and the interparticle adhesion. I call it IPA, interparticle adhesion. It's also India Pale Ale. That's a type of beer, too, if anybody knows that. And Ftir examination, of course, identification of the thermoplastic resin, and melting point determinations, if you want to do that. Here's an example of one, because all of these products have material data safety sheets in America. This is one that tells us it has 50 to 60% wood dust, carbon black, and the polyethylene matrix. And this is what it looks like. The left-hand view is looking down on the material with the wood grain finish, and the other one's a cross-sectional view, taken at two separate times, thus the color doesn't quite look right. But if you're looking at that material by light microscopy, you can start to see some of the pigment grains. And if you do some mapping of the material, you can identify, of course, the iron oxide type pigments. I'm moving along here, I'm running out of time. This is one with a rice hull filler. You can see some of the rice hull parts in it. And by electron microscopy, with backscatter imaging and different types of imaging, you can see in more detail some of the product. And you can do some more mapping, looking at the absence of iron, calcium, and aluminum in the plastic. By FTIR, this is just a quick and dirty little ATR example of how you can quickly identify the polyethylene in the sample. Another example of not a wood plastic composite, but a case involving wood on the nose of a bullet. And with light microscopy, you can actually see what are called the bordered pits in the upper right-hand picture, proving that it's a softwood material. And in the lower left-hand image, it's a comparison of a known standard of ponderosa pine on the right and the question material on the left, showing the dentate ray tracheids and the pinoid pitting and all that we're not going to get into. But the lower right-hand corner is another wood in which the investigator thought it came from. And I've stained it with iodine stain, and you can see some of the starch grains mixed in with the wood. And this was a laminated wood product, a butcher block table. Examination of hardened concrete. Concrete's very important, and that's some pictures of concrete. You can polish section cross concrete, and you can make thin sections of concrete. And if you're a geologist, you can examine it just like a rock. And examinations are via PLM mainly. And thin sections, you can see different types of interesting structures. And this is how they make Portland cement. Okay, and these are some pretty pictures of Portland cement clinker. And some of the hydration products which you can find. and some other pretty pictures of ingredients found in concrete. And some things I wish I had time to tell you about bricks. Brick manufacturing processes. I went to a brick manufacturing plant and learned how they make bricks. And it's very fascinating, different methods. And these are the raw ingredients, and they go in and extrude the brick out, and they cut it with these wire cutters. They go through a kiln, heats it, changes the temperature a little bit, well, ramps the temperature up to 2,000 degrees, makes it into a ceramic product. But the thing to know is you can identify and distinguish bricks by stereo microscope, just by the differences in their structure, they're in color. Components on brick surfaces, which we don't have time for, and there's a scheme. Everyone can snicker because there may be DNA on a brick. And brick provenance, and a case I was going to talk about in El Monte, California. I can talk a little bit. I have 2 minutes. Well, thank you very much. I can slow down now. Actually, then we'll just talk about references. You have to have a reference collection for all this stuff, of course. We all know that. Lumber yards, pulp mills, hardware stores, contacting corporations, trading with other scientists, and there they are, they're trading, their hands are flying around. And of course, interns are just great fodder for projects. And collecting in industrial sites, and collecting little bits and pieces of things, except right now while you're looking at me. You don't want to collect material from the ceiling either, it's too high. Different sites to collect. And these are just some samples of reference collections in my lab. The raw materials, subset of the raw materials, reference slides, and more slides, and a searchable database that we put together so we can find these things because they're in different areas of the micro lab. They're in a cabinet over here, they're on somebody's desk over there, and they're in other little pigeonholes, so they're all in a database. I can put in the word poplar, and I'll know where the popular poplar is located throughout the lab. Well, thank you very much.